So today's topic is probes and its labeling. First of all, probes. What are probes? Probes are generally 10 to 30 base pair long nucleotide sequences, and and their function is generally to find out a complementary sequence from a bulk of sequences. They are designed for a known sequence and they are complementary to the target sequence. So its function is to identify complementary sequence. Now talking about its labeling. We can label a probe by two methods. First is radioactive labeling, and second is non-radioactive labeling. In radioactive labeling, we generally it is done by like phosphorus 32 radioactive isotope of phosphorus, and in non-radioactive labeling example we can use biotin or deoxygenin. Okay, so these are the generally two methods of labeling. Now the methods. Talking about the methods of labeling, there are different methods of labeling like primer extension and end filling, nick translation. There are many other methods also available. Among these methods, we will discuss nick translation in details. Nick translation is the most commonly used method of labeling, and the steps involved in the complete process are as follows. Suppose this is the DNA strand which we want to label. Okay, this is the DNA. So in this DNA, a nick is introduced with the help of enzyme DNase. DNase has the capacity of introducing or of cleaving the nucleotide chain. So this discontinuity in the phosphodiester bond shown here, this is nick. So now this 3' end, free 3' end with OH group is available here. Now in the presence of DNA polymerase 1, Now, in the presence of DNA polymerase 1 and labeled nucleotides, we synthesize the So, DNA polymerase using labeled nucleotides, suppose DNA polymerase is here, it will add a nucleotide which is radioactively labeled or non-radioactively labeled. That nucleotide is taken and is added at that free 3' OH group. Now, this process continues. Here we can see that labeled nucleotides are added repeatedly and the existing strand, it is replaced, it is moving, the strand is moving. But how it happens that the polymerase enzyme, it has 5' to 3' exonuclease activity. Plus polymerizing activity. So, using these both activities, what it is doing? It is using polymerizing activity, it is adding radio labeled or labeled nucleotides at the free 3' OH group of the nick, and by using its exonuclease activity, it is replacing the existing strand in the 5' to 3' direction. So, this process continues, and after a certain time period we get a chain of labeled nucleotides. So, in this way, by using a nick translation methods, we are labeling the unlabeled DNA with labeled nucleotides. Two enzymes are used in this process. First of all, DNase 1 and then DNA polymerase. DNase 1 introduces the nick in the existing double stranded DNA, and DNA polymerase, it uses it using its polymerizing activity and exonuclease activity, it is adding the labeled nucleotides and replacing the existing strand. So, this is the method of nick translation. By the movement of nick, we have labeled the DNA. Thank you.